Okay, so today we're going to start looking at how we can construct a confidence interval for the slope. So before we do that though, when the conditions are met, which we talked about yesterday, we can do inference about regression model. The first step is to estimate the unknown parameters. So if we calculate the least squares regression line, the slope B is an unbiased estimator of the population slope beta. And the y-intercept A is an unbiased estimator of the population y-intercept A. The remaining parameter is the standard deviation sigma, which describes the variability of the response y about the population regression line. The least squares regression line computed from the sample data estimates the population regression line. So the residuals estimate how much y varies about the population line. Since sigma is the standard deviation of responses about the population regression line, we can estimate the standard deviation of the residuals by using S. So we're taking the sum of all the residuals, the y values subtracted and squaring them, and dividing by n minus 2, and taking the square root of all of that. So normally we don't know the population standard deviation for the regression line. So we estimate it with the standard deviation of the residuals S. Then we estimate the spread of the sampling distribution B with the standard error of the slope. So the standard error is the S, the standard deviation of the sample, divided by S sub x, and then times the square root of n minus 1. And if we transform the values of V by standardizing, we get Z is equal to B minus beta divided by sigma sub B as the standard normal distribution. Replacing the standard deviation of the sampling distribution with the standard error gives us the statistic T, which has a T distribution of n minus 2 degrees of freedom. So here is where they're giving you the population slope and then they're giving you the standardized slope. So to construct a confidence interval, which is what we're going to focus on today, the confidence interval for beta has the familiar form. We take our statistic plus or minus the critical value times the standard deviation of the statistic. Because we use the statistic B as our estimate, the confidence interval is B plus or minus T times the standard error of B. And we call this a T interval for time, T interval for slope. So this is just repeating everything. We're saying that if we do all of this and we find the confidence interval for slope, T star is the critical value for the T distribution with degrees of freedom n minus 2, and that means it has an area of level C between negative T star and T star. Tomorrow we'll look at how we can perform a significance test for slope. Again, there was no example in this PowerPoint, so the best thing we're going to be able to do is to watch the examples from Jason Molesky, the guy that you love, and then we'll come together tomorrow and answer any questions that you might have.